Look at this one. If I have 0.1 moles of sodium carbonate, how many moles of this is acetic acid do I need? We did a problem almost exactly like this. All I did was I changed this value to a different number. So how do we solve that problem? That's right. This one goes, what goes in here now? 0.1. So 0.1 times 2 should be our answer. Does that make sense? So this up here, 2HC2. I'm going to rewrite this so there's a little bit more space. 2HC. Okay? There we go. Now, I mean, we wrote this, we talked about this last class. 2 of these combined with 1 of these to form 1 of these and what? 2 of those. Agreed? You guys see that? All right. So, if I have 0.1 moles of sodium carbonate, here it is right here, how many moles of acetic acid do I need? We're gonna need. Can you see how to figure out the answer, Brady?
Yeah.
All right. This is already done. What? It's done. It's right in front of your eyes. It's a statement that says 2 of these plus 1 of these yields 1 of these and 2 of those. Does that make sense? There's not more to do there. It's just a statement that's going to help us answer any other problems. Okay, now here's the question. Here's the question. And then we go through our process to answer the question. What's the process to answer this question? What's the first step? You write an equal sign. Everybody grab a paper and a pen. Everybody grab a paper and a pen.
Well, we can have them on other days, but why don't we do it when we're done with our school?
Everybody grab a piece of paper and a pen. Okay?
Are we doing the chemical reactions today?
We need everybody who's here. We only got 15 minutes. All we do in here is just pay attention to chemistry. Afterwards, we can talk all day long. Thank goodness it's only 15 minutes, huh? And now it's only how much? 14 minutes. Okay, so we have a chemical equation. We have a question here, right? We have a chemical equation. We have a question. Here's a box full of pens. You can't get one that works. We read the question. After we read the question, what's the first thing we do? We write an equal sign. We write an equal sign. And then we draw a what?
A line.
A line, like this. That's correct. And then we write what?
A line.
Well, we can write a line here, that's true as well. But what goes to the right of the equal sign?
Moles.
The units that we're after. Can everybody say that? The units that we're after. Because it's not always going to be moles, it's not always going to be grams, it's not always going to be watts. You know, it's something different every time because you're solving a different problem every time. Right? So, what is it in this scenario? What are we after? And we have to, not just moles, it has to be moles of something, right? Is that one not working either?
Dada, we have to walk to there.
HC2, H3O2.
Very good.
Get a paper and a pen.
Moles of Na2CO3, is that what, no, sorry, moles of HC2H3O2, which is called acetic acid. So moles of HC2H3O2. All right? Got it? There's some more paper over here on the couch. Did everybody see that? Now, what do we start after we write what we're after? To the right of the equal sign, moles of HC2H3O2. We write what we're provided, what we're given in the question. And what is it that we're given in the question?
0.1 moles of
That's right. Moles of Na2CO3. And that's 0.1 in this case, okay? And now we try to get these units to be like these units by using what we call conversion factors. All right, so what's the conversion factor that we need here? What units do we have to have down here?
You have to have NaCO3.
That's right. We have to have moles of Na2CO3 to cancel out these moles. And what would we like to have up here?
HC2.
Yeah, moles of the acetic acid. So, moles of HC2H3O2. Now, do I know a relationship between these two things?
2 HC2H3O2 combines with 1 NaCO3.
That's right. The ratio here is 2 to 1, and that's shown to me by my equation that I had to balance. We balanced this equation 2 days ago, remember? Was that yesterday?
Yeah, yesterday.
All right. So, this balanced equation tells me the ratio. It tells me for every 1 mole of these, I need 2 moles of these. So then I can take 0.1. How do I know I'm done? Because the units that I'm after are now the units that I have right now, right? I've arrived. So I can cancel out those. I can take 0.1, multiply it by 2, and divide it by 1.
1.
So what's the answer?
0.1.
0.2. So put in your calculator 0.1 times 2, and then that should be the answer, 0.2.
What do you have to divide by 1?
Yes, you can do. That's right. Divide by 1 you can. So, does everybody have a calculator?
No. I need one. Hey.
Did you get it? Way to go! Fabulous!
Got it.
Okay. So, we put in the calculator 0.1 and multiply it by 2, and that should give us our answer then.
0.2.
All right,
Divided by 1.
divide by 1. Very good. So, we're going to move on now. Hopefully you understood how to do that, because the next question is going to require more of that. Okay? So here's another question. If I have 0.7 grams of, actually I'm going to make this 3.7 grams of Na2CO3,
What did you do?
how many
I just put a 2.
moles of HC2H3O2 do I need?
Moles of HC2H3O2.
Moles. Okay? We're going to need our periodic table. Take a periodic table and start handing it out.
Divided by. How did you?
Go.
Divided by.
Maybe you guys can share one.
It's divided by what? 0.1 divided times 2 divided by 1. Oh.
Okay.
Times 2. Okay, so
Now,
0.
to solve this problem, what do? We have to follow that pattern.
2
What do we do to solve this problem?
divided by 1.
You write an equal sign. And then we draw a line like that. Breathe out. Did you breathe out?
Yeah.
Okay, what goes to the right of our equal sign?
A line. A line.
Units to the left. We go to the left. What goes to the right? Units. Which units?
The units.
That's right. Moles of HC2H3O2. That's what I'm after. Okay? What goes to the top left here? What units? How do we identify this? We have to read through the problem again and figure out what we're looking for. And not just Na2CO3. What of Na2CO3? 3.7 grams of it, right? 3.7 grams of Na2CO3.
So we have to use our calculator and work then, right?
Well, in a bit. What units go down here? It has to be Na2CO3. How do we know that, gentle people? How do we know that it has to be grams of Na2CO3 down here?
So
Because the
they
units need to cancel out.
Grams is not what we want.
Right. So grams of Na2CO3 goes down here. Now, what should go up here?
Well, it should be moles of
Yeah, but I don't know a relationship between the moles of this and grams of this. We have to first go to the land of the moles. We're on a journey here to solve this problem. We have to go to the land of the moles. How can I convert grams of Na2CO3 to moles of this? Well, first I have to know moles of Na2CO3. Moles of Na2CO3. So it's going to go grams of Na2CO3 to moles of Na2CO3. What's that? You don't get it? Which part? Why we went to moles? Is that what you're wondering about, Lamont? Okay, so we went to moles because up here I have a statement that says 2 moles of this plus 1 mole of that. That's the ratio. And if this is my land of moles. If I can get up here and find the hiding power of the equation, then I can use that power to solve this problem. How would you convert grams to moles? That's a good question.
If it's just one,
Yeah, if it's just one element, we look at there. But when it's lots of elements like this, Na2CO3, what do we got to do? We got to add them all together. Any one extra piece of paper around that I can use?
How many names of
oh, well, there's 2 NA and 2 NA.
Here it is. Watch this. It's Na2CO3, correct? All right. There's 2 NAs. How many carbons are there?
3.
1 carbon. How many oxygens?
3.
3 oxygens. So, 1 Na is how much? What's the periodic table say? 23. So I need 2 NAs. 23 plus 23. That's 46. So there's 46 from the sodium. What's carbon? Can you guys see carbon? Can you tell me what carbon is?
12.
12.
Right below there it says 12. See that?
12, all 1, 1.
Can you see the 12? Everybody see the 12? Tom, do you see the 12? Oh, that's a nice picture, Tom. Carbon is 12. And what is oxygen? 16. But I need 3 of them. So put in your calculator 16 times 3. What is it? 48. Now, if I add this up, 46 plus 12 plus 48, 106. That's how many grams I need to do what? To get 1 mole of that, I need 106 grams.
Now we need to put 106 there.
That's right. So,
106 by the moles, right?
Do what?
what is this 106?
106 grams.
How many grams I need to get what? 1 mole.
Not
So
long.
106 grams
Not
of
long.
this stuff gives me 1 mole. Now, I'm in the land of the moles. Welcome to the land of the moles. We must now find the power of the what? Of the equation. The power of the equation to solve our problem. Just like you
We
need to
didn't
travel.
change anything.
We're not done. We're not done. Right? We didn't change anything. Change anything to make it into moles? Yeah, we use the conversion factor. We use the fact that there's 106 grams for every mole to get into the power of the mole, or to the land of the mole. All right, now are we done? No, we're in moles of sodium carbonate, and we need to be in what?
Moles of
Moles of acetic acid. Okay? What do we do now? What goes down here? What goes down here, Emma? Yeah, what does it have to be? Yes, it has to be the same thing because we have to cancel this out. So moles of Na2CO3. And what goes up here?
moles of H.
This stuff, right? Moles of HC2H3O2. Very good. Do I know the ratio? I'm in the land of the moles. I should be able to identify the ratio.
Yes. 2 at the top.
Yeah, 2 of these for every one of these.
We don't have enough grams to eat one mole of it.
That's all right. It'll be a fraction. So, if I start off with 3.7 grams of this stuff, I find out how many moles it is. See, these grams of Na2CO3 cancel out, and then the moles of Na2CO3 cancel out, and then I'm left with moles of HC2O32. So, to solve this problem in the calculator, what do you have to do?
Multiply 7 times 2 divided by 100.
That's right. Put that into your calculator.
What? 926.
Solve this problem in your calculator. And if you didn't quite hear what he said, remember, you just multiply everything on top and divide everything on the bottom. Alright? Okay, so let's try it. Start over here. We're going 3.7.
It's
3.7
0.0698.
times 2. And then divided by 106. Divided by 106. There you go.
98.
Wait,
116.
what's the E?
No, 106. 106.